Assume that the speeds of automobiles on an expressway are normally distributed with a mean of 62 miles per hour and a standard deviation of 5 miles per hour. We want to know what percentage of cars are traveling slower than 55 miles per hour. All right. Well, we were told that the speeds were normally distributed. So I'll start with that bell-shaped symmetrical curve. And I'll put the mean right in the middle. That's 62 miles per hour. Now we want to know what percentage of cars are traveling slower than 55 miles per hour. So think of this like a number line. 55 is just lower than below 62, so it'll be to the left. And we're interested in the speeds that are slower than that. So I'll shade to the left. These are miles per hour. Our next step would be to standardize these values. By standardizing them, I mean convert them to z-scores. The mean has a z-score of 0. Now for 55, I use the formula, the value minus the mean over the standard deviation. So in this case, the value is 55 minus the mean of 62 over a standard deviation of 5. I get a z-score of negative 1.40. So 55 is 1.40 groups of 5 below 62. Now use the table to find the area to the left of that z-score. All right, so there's a negative z-score. I'll go down to the negative table. Under z, I'll find negative 1.4. Now for the hundredths, I have to find that across the top. Well, it's 0 hundredths. So where they intersect, I have an area of 0.0808. So the area from the table measures the area to the left of the z-score we looked up. Now to answer the question was, what percent of cars are traveling slower than 55 miles per hour? So I'll move the decimal point 2 places to the right, tack on a percent sign. Now if we want to know what percentage of cars are traveling between 55 and 65 miles per hour, let's draw our curve, putting our mean of 62 miles per hour in the middle. 55 miles per hour is less than the mean to the left. 65 miles per hour more than the mean to the right. These are miles per hour. So when we standardize these, we know the mean has a z-score of 0. We just found the z-score for 55 miles per hour. That was negative 1.40. So for 65, it's the value minus the mean over our standard deviation. So I get 0.60. Well, our next step would be to convert these z-scores to areas. Now, remember, I want to find the area between these two values. The table won't do that for me. What the table will do is give me the area to the left of the z-score. So the area to the left of a z-score of negative 1.40, we did that already in the last example. That was 0.0808. Now, for the area below the z-score of 0.60, go to the positive table. 0.60, so 0.6 under z, 0 hundredths. So I get 0.725 0.57. That's the area to the left of the z-score we looked up. Well, neither one of those areas are the areas that we want. But if I take the larger area and subtract the smaller area, I'll get that area I shaded, the area between. So I get 0.6449. So to answer the question, what percentage of cars are traveling between 55 and 65 miles per hour, just with decimal point 2 places to the right and tack on a percent sign. 64.49%. Now to find the percentage of cars that are traveling faster than 65 miles per hour. I'll draw my curve. The mean in the middle. 65 is more than the mean to the right. Now faster than that, I'll shade to the right. That's miles per hour. Our next step would be to convert these values to z-scores, or standardize the values. The mean we know has a z-score of 0. For 65, we just did that. That was 0.60. So I'll use my table to find the area to the left. That's all my table will do, the area to the left of that z-score. Well, we did that. The area to the left of a z-score of 0.60 was 0.7257. Not the area we want. What we have to do is take the whole area, the area of the whole curve, which we know is 1, or 100%, and subtract that part that we don't want. So it's 1 minus 0.7257, and that gives me an area of 0.2743. And since what we wanted to know was what percentage of cars that were traveling faster than 65 miles per hour, what I get is 27.43%. So if 200 cars are traveling on the expressway, how many will be traveling faster than 65 miles per hour? Well, we just found out what percentage were traveling faster than 65 miles per hour. It was 27.43%. So 23.4% of the 200 cars are traveling faster than 65 miles per hour. So got the percent sign, multiplied, move the decimal 2 places to the left. Of means times. So I get 54.86 cars. Well, you can't have 86 hundredths of a car, so I'm going to round it off and say approximately 55 cars out of the 200 were traveling faster than 200 miles per hour.